The roof on a house has a 6/12 pitch. This means that when viewed from the side, the roof line has a rise of 6 feet over a run of 12 feet. So rise of 6, run of 12 means that's a 6/12 pitch roof. Find the angle of inclination from the bottom of the roof to the top of the roof. Express your answer in decimal degrees rounded to the nearest hundredth of a degree, so that's 2 places. And I know we just changed our calculators to radians. Yes, you have to be good at changing back and forth. So this one specifically asked for the angle in degrees. If it doesn't say degrees, you should plan on doing radians. But usually for real life problems like this, we do degrees. Like practical, types of things like this. So how do we do this problem? Let's see. So calculator in degrees, let's remember that part first. Did anyone need help changing the mode on your calculator? You all know how to do that, okay? All right. Calculator in degrees, and then basically what we're doing is we're setting up a problem. Which trig ratio would we use for this? We have 6, which is opposite our angle. We have 12, which is adjacent to our angle. Which trig ratio does that involve? You decided it was tangent. You are correct. So tangent is opposite over adjacent. So theta can be easily found by doing the inverse tangent of 6/12, which is seriously just 0.5 or 1/2, right? Why do we keep doing 6/12 when it's just reducing to that ratio of 0.5? It looks like an S when it's supposed to be a phi. You could just type in the 6/12 if you don't want to confuse yourself. I just thought, why not? Okay, so inverse tangent of 0.5 gives me a roof pitch of 26 point. This answer sounds familiar. I feel like we did this answer when we did that very first problem today in degrees when we were supposed to do it in radians, but we got this answer in degrees for that one because that was a tangent problem, wasn't it? Ta-da! Now we know what angle to make our roof. Yay! You probably already knew how to do problems like that, I hope. If not, that's a good little reminder. Okay, next one. It's approximately the same idea, just using a different ratio to find a different angle in a different problem. Did you need to see this a little longer, or are we good? Okie dokie. Okay, number 4. So here's the angle we're trying to find. This side is adjacent. This side is the hypotenuse. So to find this angle, we want to use which? Sine, cosine, or tangent? It's good to review these problems that we once thought were hard, and now they should be easy, unless we've forgotten. Cosine, yes, very good. So cosine of this angle would be 9/12, adjacent over hypotenuse, so that means to find our angle, we're just going to do the inverse cosine of 9 divided by 12, or you could reduce it to 3/4, doesn't matter, it's the same ratio either way. And again, we want our angle in degrees. It doesn't say degrees. Uh-oh, what did I say about things that... It doesn't specify, so I'm going to specify it for you. We're going to say it's in degrees, because pretty much anytime you're doing a triangle problem, like where you're actually finding the measurements in a triangle, like the stuff you learned in math secondary 2, then you would leave it in degrees. So I'm going to make an executive decision, even though I just got done saying if it doesn't say degrees, do radians. When in doubt, do both. 41 point. Do we need a decimal? It doesn't even tell us how many decimal places. Why are some of these problems so specific and others are not? Maybe I should complain about this. to my textbook committee friends. Make things a little more consistent. Maybe it's just to help you understand that sometimes things are specific and you should follow those specific instructions. But sometimes for like real life stuff, if this was representing an actual triangle that you needed to solve for some project you're doing, then you get to decide. Do you want the angle in radians or degrees? Do you want decimal places? You know, it's up to you and how accurate it needs to be for whatever you're doing it for. Okay, there's our solving triangle problem.